Hi guys, so today it is the third application of Gauss law and we'll study this today. So it is the electric field due to charged spheres. Sphere. Now the sphere is of two types, as you all know, and if you do not know, then I am telling to you. A sphere is of two types: hollow sphere and solid sphere. And in this also, conducting hollow sphere and non-conducting hollow sphere. Here also conducting solid sphere, solid sphere. I am not writing in full form as you can understand this easily. And non-conducting solid sphere. So it is of two types, and in two types also four types are there, but three types of sphere are same, means these both are same, and this conducting sphere is also same as this, means this and this is same, and this fourth one is different. So we have to find electric field due to charged sphere for these three only one time, and for this we have to do again all this we have to find electric flux for this non-conducting solid spheres. So first we will find the electric field due to conducting, non-conducting hollow spheres and conducting solid spheres. So let's write the heading first. So I have written the heading: conducting, non-conducting hollow spheres and conducting solid spheres. So in this also two cases are there, inside and outside. Inside means inside Gaussian surface is present inside the sphere, and outside means Gaussian surface is present outside the spheres. So first we will take the case of outside. So put the heading outside. Outside, so let's draw the sphere first. This is the symbol. Let's take a new page. Outside. Now I am drawing a small sphere because we have to do outside, means Gaussian surface will also come, but it is outside the surface. So this is the Gaussian surface. Remember students that this radius should be different for different spheres. For Gaussian surface radius is different, and for sphere radius is different. In future, means here only, in this application only, you will study 6 cases of this application. So put the radius of sphere same in all the cases, and put the radius of Gaussian surface same in all the cases. So this will not create any confusion in your mind. So this is the sphere. It is the capital R I am taking for the sphere, and this is the small r I am taking for Gaussian surface. Now I am taking capital R for sphere, so I will continue with this R only in future for sphere, not for, I cannot change this capital R for Gaussian surface R. Please don't do this. This will create a mess in your mind, or you will greatly confused due to this. So in this case, small r is greater than capital R. You can see this in the figure only. Let's see the charge. It is a sphere, so it is only have the charge, and it is a conducting, means charge should be present here. Remember, don't draw these charge here. Charges are drawn on the boundary of this plane. Please don't draw charges on the Gaussian surface. Charges never come on the Gaussian surface, remember this. So I'm zooming in. Okay, now we'll see the electric field due on Gaussian surface. It is here, electric field will come here, and area also come here, means theta will come 0 degree. This case also electric field is here and area is here, theta is 0, though there is no need to find different for both. Let's find the flux, and now we'll find the flux through this formula. E D. It is the symbol of closed. It is closed, and this we'll find for this surface. It is closed, so I'm doing this. Remember, in last two application I haven't drawn this because they are not closed. They are till infinity. The plate was till infinity. I have to put this just to show them, otherwise this type of plate was there. So forget that. We'll do this now. Electric field A cos 0 degree equals to E, or you can write E 4 pi r square. Okay, now we'll find electric flux for Gaussian surface, means Q inside upon epsilon naught. Now one new term will introduce here, but here there is no need to introduce that term because charge is not present inside the sphere, so where there is no need of volume. Otherwise we'll use volume density in applications with means in a non-conducting solid sphere we'll use volume density. Here it is in this, so we'll put areal density here, means equals to Q upon area. I know the diagram is not so clear, but you can understand this. Otherwise at the end I will draw fair diagram of this. So this Q equals to this is sigma 4 pi r square upon epsilon naught. Let's give this equation 1 and this equation 2. So equation 1 is equals to equation 2, E 4 pi r square, and in this case E 4 pi r square. You can see that here I have taken a small r, and you know the reason, because this is fine only for Gaussian surface and this is the Gaussian surface. So let's cut the values which are similar. Electric field is equals to r square upon r square epsilon naught. This is the electric field for outside. You can remember this formula, and there is no need, so much need to remember this, as if we remember the formulas it creates more confusion. Remember this derivation, it is more helpful than remembering the formulas. Okay, so I'm drawing a fair diagram of this here so you can understand this more. So see, I have drawn the fair diagram. Electric field is this, area, small area dA this, but we have taken capital area here because it is uniformly charged. This is uniformly charged. See students, you can notice this thing, that if this charge act as a this is sphere act as a point charge for Gaussian surface, means this sphere is so much small than Gaussian surface, then it can act as a point charge. Then in this case electric field will be kq upon r square. Write the reason that cut this. Let imagine that sphere act as a point charge for Gaussian surface, then in this case only formula of electric field will be this. Otherwise, remember this is more helpful than this. It is only the some students ask that ma'am, this act as a point charge. So for this also happens, this is also possible, but it is more important because it is the new one. This we know earlier, so it is the new one. Okay, so my advice is that remember both are helpful equally. Okay, thank you so much, students. Please share my channel, subscribe my video, and like my video. Okay, thank you, students. Please share my channel, subscribe my channel, and like my videos. Thank you so much.